Hello, my name is Patrick, and today I will show you how I manage my self-hosted backups using Restic and MinIO. I currently store my files on a server in my basement. The server does have a parity drive, so a single hard drive could fail without any data loss, but this isn't enough for a good backup solution. If multiple drives were to fail at once, or if a disaster like a flood or fire ruined the server, the data would be unrecoverable. To solve this problem, I want to build my own backup solution and self-host it. This is mainly for fun and for a learning experience, and admittedly, I'm not trying to sell this as a superior solution to software like Dropbox and Google Drive. However, I am backing up terabytes of data, and I want to avoid the recurring costs of using a service like that for backups. I'm going to first get this set up on my local network. I'll be using a Raspberry Pi 4 and a 4 terabyte external hard drive. After it's all working on my local network, I'll move the entire setup to my parents' house and then put it behind a reverse proxy for access. This is going to make it so that if something were to happen to my house, I should still be able to access that data. There are a lot of steps in this process, and I'll do my best to go over everything in detail. But I've included timestamps in the video. Feel free to follow along or skip over parts that might not apply to your setup. Restic is my backup CLI of choice because it has encrypted incremental backups. And I'll be using Autorestic, which is an abstraction on top of the CLI that defines all the configuration in a YAML file. MinIO is a fantastic project that lets you host a file system as an S3 compatible endpoint. Restic works with S3 backups, and hosting our own S3 endpoint will be how Restic and our server communicate. Lastly, I'll go over some networking. My parents' house does not have a static IP address, so this may change over time. I'll be using DuckDNS and a DuckDNS client to make sure that the domain and the IP address stay in sync. And then I'll be putting the MinIO server behind an Nginx reverse proxy. I'm going to be using Linux Server IO's Swag container, which has Let's Encrypt built in for generating and renewing certificates. This is going to allow all the traffic to the server to be HTTPS. I'll be using Namecheap for the domain. You don't need a domain for this project, but it's going to make it a little cleaner. And you also don't need to use Namecheap. You can use your preferred domain provider. At the time of recording this video, Raspberry Pi's official images are all 32-bit ARM operating systems. This is going to be a problem since the latest release for MinIO, just released 3 hours ago, only supports 64-bit operating systems. If I look for the latest 32-bit release, it goes back 7 months ago. Because of this, I'm going to opt to use Raspberry Pi's 64-bit beta operating system, which I can download from here. I'm going to include all links in the video description. I'll download the light zip, save this file. The Raspberry Pi Imager is one of the easiest ways to write the image to the microSD card. I've already installed it, so I'll show you how to run it. First, you choose the operating system. If you look at the official images here, they're all going to be 32-bit. I'm going to avoid those and choose the custom 64-bit image that I downloaded. Then storage, and perform the write. Now that the image is written to the SD card, I'll go over the hardware setup. I'm running a headless setup, so I don't have a keyboard or screen hooked up to the Pi. So there's one extra step that I need to do before I put the SD card into the Pi. And it's a trick so that when the Pi boots up, it will open up its SSH connections. I'm going to list my block devices on my computer. I still have the SD card inserted. I see that I have SDA 1 and 2. The smaller partition here is the boot partition. I'm going to go ahead and create a directory just called Pi boot. it already exists. It's okay. I'm going to mount, I'll need sudo access to mount device SDA1 to Pi boot. Once I'm in here, I'll be able to see the files that are in that boot partition. I don't care about any of these. I just need to touch a file called SSH, and I'll need sudo for that as well. Now that that SSH file is there, when the Pi initially boots up, I'll be able to SSH into it. Our hardware setup is going to be pretty straightforward in this video. All we're going to have is the micro SD card that we just wrote the image to into the Pi. Then this is a 4 terabyte external drive that I had laying around. I'm going to make sure that that's plugged into one of the USB 3 ports onto the Pi. Both are going to need power, and then I'm going to give the Pi internet, Ethernet access. Okay, everything should be up and running. And now I'm going to go try to find the IP of this new Pi on my local network. This step will vary depending on what type of router you have, but after I plugged in the Pi, I saw a new unknown device show up, and it's under the IP address of .205. Now we're going to SSH into the Pi for the first time and take care of some housekeeping. We're going to need to SSH with the Pi user. And the default password is raspberry. Excellent. So now the very first thing that we'll want to do is update the Pi. Now that we've finished updating, I'll adjust a couple other configurations using a utility called raspi config. Go into system options, and I want to change the password for the Pi user. Next, I'll change some localization options. I want to select and make sure that EN US UTF-8 is the locale. Right now, by default, it's Great Britain. I want EN US. And that should be all that we need to do to finish setting up the basic configuration on the Raspberry Pi. Depending what Linux distribution you're using to log on to your Pi or what terminal you have installed on your Pi, you might run into this issue that I have run into, where clear commands don't clear your terminal, and it's making this xterm termite assumption. Termite is the terminal that I'm using currently to SSH in, but my Pi doesn't know anything about that, which is why I'm getting this error. To fix that, the easiest thing to do is export the term variable and just call it Linux. And now commands like clear will work fine. Next, we'll configure the Pi to automatically mount the 4 terabyte external drive on boot. First thing that we're going to need is some information about the external hard drive and make sure that the Pi can actually see it. That we can do with the list block devices command. I'm going to use -F to display the types and UUIDs of the devices. Here I do see the external drive. It has an exFAT file system, and I'm going to make a note of the UUID here and copy that. So I'm going to need somewhere to mount it. That can be anywhere. I'm just going to make a directory called data in the home directory. To mount the drive on every boot, we'll need to edit the fstab file I've installed NeoVim. You can use any text editor that you want to edit this file. I'm going to use NeoVim to edit the fstab under the etc directory. Here we'll first write the UUID that we just copied. And then we'll include the place where we want it to be mounted to. Home Pi data. The type of the drive, which was exFAT. And then options. So I'm going to use defaults and read write. And there's one extra thing that we need here actually, which is the UUID and GID of the user that we want permissions for to access the drive, and then 00 here. I don't have the UUID and GID yet, so I'm going to save and quit this file, and then I'm going to run ID Pi. So it's going to give me that information about the Pi user. It's 1000 and 1000. So I'm going to go back into that file. 1000 and 1000. Write that file. And now that hard drive should be mounted on boot. I'm going to go ahead and reboot the Pi now to confirm that that works. The Pi has rebooted. I just SSH'd back in. The data directory is still present, and if I list my block devices again, I can see that the external drive is mounted to that directory. I can cd in and see that I have some old backups and files on this external drive. That shouldn't impact too much because we're going to be creating a separate directory entirely for managing the MinIO file system. I'm going to make sure that I can touch a file just to make sure that permissions are working properly. That looks great. We can move on to the next step. We're going to be using Docker and Docker Compose to manage the containers for this project. So I'm going to install those with apt. Now that Docker is installed, I'm going to go ahead and run the Hello World container just to make sure that Docker is running properly. Okay, I see hello from Docker. It looks like that container ran properly. So I've confirmed that the Docker installation on the Pi is successful. Next, we're going to start up MinIO server on the Pi using some example commands on the Docker documentation. They mention at the bottom of this documentation that if you want persistent storage, you will have to use this -v for volume to specify the directory that you want to have persistent storage on. So we do want that. I'm already in the directory that I want that storage in, which is home pi data MinIO. So I'm going to copy the docker run command. It does need to be ran with sudo. I'm going to back up to the run command and use -v. I want to copy the directory that I want the persistent storage to be in, use a colon, and then the next argument is the directory in the container itself, which is actually what I'm passing. So the /data that I'm passing to the server. I run /data, and I can run that command. And we can see that the server has started up on port 9000. So I can go to the Pi's IP address, port 9000, and it's going to ask me to log in. There is some default credentials, and here we are. This is the MinIO server browser. I'm going to go ahead and create a bucket just called test. Now I have a bucket test. I'm going to create a separate SSH connection to the Pi. Go to data MinIO ls, and there's that test directory that I just created on the MinIO server browser. So that confirms that MinIO server is correctly working on the Pi, but this is not going to be the end state of how we're configuring the system, we're going to now move this configuration into a Docker Compose file. A Docker Compose file is going to let us define this run configuration parameters in a YAML file. This makes it easier to manage containers without having to remember all of these parameters each time, and it's also going to let us define multiple containers inside of a single file. Before we go ahead and do this, I'm going to do a couple quality of life improvements just for our Docker setup. First is I'm going to go ahead and run sudo group add docker. I think this is already present. It is. So this is creating a Docker group. If you do not have it, go ahead and create one. Next, make sure that your user that you want to run Docker with is added to that group. And that is the usermod command, add group, Docker, and then the user I want is Pi. And then that will let me run the Docker commands without having to type sudo each time. So I can actually just confirm that now. Normally you would have to log in and log out, but I've already added Pi earlier to that command. Perfect, that ran. So I no longer need sudo to run Docker commands. Next is I want Docker to spin up when the Pi boots. The reason being is power will not be consistent to this device by any means. Like if the power goes out, I want to have this configured in such a way where it will spin itself back up into a good state. That's pretty straightforward. All we need to do is use systemd to enable the Docker service. And now every time the Pi boots up, Docker will start up automatically. Next, we'll start writing our Docker Compose file for MinIO. I'm going to create a new directory called Docker. Docker Compose uses the standard file name docker-compose.yaml. And we're first going to define a version. If you haven't used Docker Compose before, it's pretty straightforward. It's very similar to the run command, except it's going to be configured in this file. So we're going to define a list of services. And the first one that we'll have in the file is MinIO. This is the name of the service. It doesn't need to be MinIO. I'm just going to call it MinIO. The image is what's going to specify what we're actually wanting to run, which was MinIO/MinIO. We're also going to specify what command we would like to execute, which was server/data. And then we also have ports that we want to expose through Docker. That is port 9000, and it's also 9000 inside the inside the container. We also had volumes. This was to mount the external hard drive into the data directory as well. This was home pi data MinIO. That maps to data inside of the Docker container because that's what we're passing to the command. Next, I'm going to add configuration, and it's called restart. And I'm going to say always. What this does is when this service is running, if for whatever reason the host restarts or Docker restarts, it's automatically going to restart this service as well, which will give me that desired behavior of the power going out, power coming back on, and this spinning itself back up automatically. Lastly, I need some environment variables. We didn't do this before. Spelled environment wrong. We need some environment variables. This is going to actually let us set our root user and root password, which is important if this is going to be exposed to the public internet. Put some junk here for now, get that more secure later. So now that the Docker Compose file is up and running, we can test it by running Docker Compose up. And we see very similar output to what we saw from the Docker run command. I'll go to Firefox and we'll do the exact same thing. 192.168.0.205, 9000. I'm already logged in, but I'm just going to log out and make sure that the access key and the secret key are now the new ones. Excellent. Okay. So now we have Docker Compose running. Let's go ahead and test to make sure that it will reboot itself in the case of the Pi restarting. So I'm going to do Docker Compose up and -D to have that run in the background. Excellent. So this should still be up and running. Great. Now let's reboot the Pi. Sudo. Okay, so my expectation here is that this should just time out. It's not able to connect. Let's give a second for the Pi to reboot. All right, so the MinIO browser just started back up. I should be able to SSH back into the Pi. And we're good to go. Next, we'll configure Autorestic to back up a local directory on my desktop to the MinIO server on the Pi. First, let's go ahead and make sure that Autorestic is installed and on your path. I have already installed it, and the quick start guide on Autorestic's website has a quick curl command to do that. Autorestic configuration is going to be by default in your home directory on .autorestic.yaml. I'm going to create that file now. And I'm going to copy and paste the sample configuration that they have on their website. Locations are going to define directories that we want to back up. So first, let's create one. I'm just going to create a test one. So we'll just call this Restic. And if I go into Restic, present working directory gives us the full path. And then the 2 is going to specify the backend that we want to back up to. I'm going to rename this to MinIO server. That corresponds to a backend. I'll go ahead and rename the remote to MinIO server. And I'm going to delete the local hard drive external storage. It is an S3 backend. MinIO mimics S3. The path is not going to be through Amazon though. So what we're going to do is specify the path on our local network. This is going to be the address to the Pi. And then we're also going to need to specify the bucket that it goes to. So it's going to be / the bucket name. I'll call the bucket name Restic. That bucket does not exist. So I'll go over to the MinIO server browser and create Restic bucket. The key is very important. This is what's going to encrypt the data before backing up. And this is the encryption that'll be at rest on the MinIO server. If my desktop were to be destroyed or all the hard drives fail, I would lose this file alongside my files. So the key is something that you're going to want to back up as well, off network and off the computer that you're attempting to back up. So this is a very important key. You'll want to make sure you have a copy of that. The access key and secret key are what we set up in the MinIO Docker Compose file. All right, that is good to go. What we'll do is now run the command autorestic backup -a, and I'm actually going to wait on that because there's nothing to back up yet. So I'll just touch an X file. And now we have actually something in this directory to back up. Autorestic backup -a. This is an error that I'm receiving. It's looking for a config file in the Restic bucket. There is no config file, and the reason this is happening is because I was already playing around with some configuration before. If you are setting up multiple Autorestic configurations and you're playing around with this, you might run into the same error. What you do here is you first need to forget the configuration. So you run Autorestic forget -a. That's going to sort of give you a clean slate to work with. I should now be able to run the backup command. And it says it's done. If I go over and I refresh in the MinIO server browser, I can now see a bunch of data that the Autorestic command put into this bucket. And if we go into data, we can see that these are binary blobs of encrypted data. That covers the basic setup on how to back up data to the MinIO server. Now let's go over how to recover that data. All right, so I'm going to simulate some data loss by just removing the Restic directory that we just backed up. To restore that, I'm going to go ahead and use Autorestic restore. You provide the location that you want to restore, and that's the location that you've configured. So that's going to be home. And you can say where you want that restore to go to. I'll call it Restic. So it finished restoring from the server back onto the desktop. If I cd into that Restic folder, I now have my X file back. At this point, we have a working MinIO and Restic backup solution on the local network. I've decided to split this video into a couple parts, and in the next segment, I'll move the Pi to my parents' place, put it behind a reverse proxy, set up a dynamic DNS client, and configure a subdomain CNAME to point to it. Feel free to leave questions and feedback in the comments, and if you like this content and interested in seeing more, let me know by liking this video and subscribing. Thank you.